Hi everyone, here is a topic that I can almost guarantee is going to be the first question on your final exam. So here's a definition I want you to get down. In fact, I'd pause the whole video and get this down and then listen to me talk about it. Okay, let's define the slope of a curve at a point. The slope of a curve, y equals f of x, at the point a comma f of a is the number m stands for slope, equals the limit as h approaches 0 of f of a plus h minus f of a all over h. The tangent line to the curve at P is the line through P with this slope. So before we even focus on this formula, let's talk about what this is finding. And maybe we want to just give it an actual number so it's not so many variables. Let's let our a be maybe 2. And let's talk about our f of x as being the graph x squared. So if I graph, that's a combination of graph and draw, y equals x squared, my f of x, and I want to talk about the point a equals 2. Okay, well, if I have a equals 2, that means that I plug in 2 into here and I get 4. So I've got the coordinate 2 comma 4. So for a equals 2, I have the point 2, 4, which is roughly, I don't know, right here. So what does this formula find? Well, it finds the slope of the tangent line. Okay, so m, let me go ahead and, I'm really into colors these days. Highlight the m there, and m is the slope of the tangent line at that particular point at a equals 2. So m equals the slope of the tangent line. You might be saying, hey, why is this so important? So let's talk about that now, and then we'll deal with this formula. I don't want you to get overwhelmed by it. It's not as bad as you think. Let's recall this question we talked about on the very first day of calculus. The question says, how could we find the instantaneous speed at t equals 3 seconds? Well, as a reminder, the instantaneous speed is the same thing as the slope of the tangent line. And if you remember, speed is going to be equal to distance divided by time. Sorry about that. So distance over time. So we can also think of that as change in y over change in x, which is equal to slope. And if you don't believe me, if we're talking about a graph, we usually have our time on the x-axis and we have that distance, or even sometimes that height on the y. And that's why our slope ends up giving us our speed, because we're doing distance, the y value, right? If we subtract heights, that tells you how far something has traveled, or the distance, divided by the x, which is time. So speed, or you could even say velocity if you want, we know speed is the absolute value of velocity, is going to be the slope of the tangent line at that point. This is definitely something that you put to memory. So just as a reminder, how did we actually solve this problem? I was nice enough to not put it on your quiz, but you've certainly seen this problem before at the start of this unit. So how did we find the instantaneous speed at t equals 3 seconds? Well, as a reminder, we chose 2 points, 2.99 and a 3.01. And we did change in y over change in x, right? F of 3.01 gives me a y value, f of 2.99 gives me a y value, and then you're subtracting your x values in the denominator. I want you to put this in your mind right now, because I'm about to say that what we are about to do with our formula looks exactly like that. Not quite exactly, but you'll see the similarities. All right, so put that in your mind. All right, looking at this formula right here, it says the slope is equal to f of a plus h minus f of a all over h. Well, what would we have done on the last page? We would have made time equal to 2.01 and maybe time equal to 1.99. But we could have also very easily chosen time equals 2 and time equals 2.0001. And then we would have just done the same thing that we did here, where we plug in those values to get y values in the numerator, and then we subtract the x's in the denominator. All right, so looking at this here, I'm just going to plug in a is equal to 2, and maybe not write this down. I'm just trying to explain to you why the formula works, and then I'll show you why that looks very similar. So if I plug in a is 2, and I have h approaching 0, let's just say for the sake of understanding that h is equal to 0.0001. So then a is 2, so we have f of 2.0001 minus f of 2. And then you should say, hey, Ms. Sorensen, I know what to do here. You just do 2.0001 minus 2. That's what we would have done here. Just subtract those two numbers that are really close. Well, what is 2.0001 minus 2? Well, that's just a plain old 0.0001, which is h approaching 0. So we can just think of this as h, because h is that number really close to 0. And so essentially what this problem is doing is it's finding the slope. It's just using the point 2 and a point really, really close to it. And it just so happens that our x's cancel in the denominator and we are just left with an x. Sorry, just an h. I'm going to say that one more time. It's really important conceptually. What is this formula doing? It is just finding the slope of x equals 2 or time equals 2 and a point that's really, 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 really close to 2 seconds. And that's why we have that plus h, because we know that it's really close to 0.000000000000001. All right, and so that is going to give us our slope at that point. Okay, so enough of that conceptualization. Let's go ahead and let's apply this formula. So we want to find the slope of the line tangent to the curve x squared at x equals 2. So it's literally saying I've got my x squared graph. It wants to know at the value of 2, what is the slope of my tangent line? And same thing that we were talking about earlier. So slope equals what for that green? So we've got the limit as h approaches 0 of f of, well, my a is going to be 2. So we're going to have a equals 2, so that's going to be 2 plus h minus f of 2 all over h. So all I've done so far is put in a 2 for a. Next thing I'm going to do is I'm going to plug in. Anytime you see this notation f of 2 plus h, that's a fancy way of saying anywhere you see an x in your problem, put in a 2 plus h. So this is going to be the limit as h approaches 0. I'm going to take this 2 plus h and I'm going to put it in right here. So that's going to give me 2 plus h squared minus, well, what is f of 2? Well, that's just plugging 2 in. So what do I get when I plug 2 in? I get 4, all divided by h. Let's go ahead and let's FOIL this 2 plus h quantity squared. So I'm going to write this here. That's 2 plus h times 2 plus h. 2 times 2 is 4. 2 times h is a 2h. H times 2 is a 2h. And an h times h is an h squared. So that gives me 4 plus 4h plus h squared. At this point, you might be able to do that in your head. So I'm going to rewrite that. The limit as h approaches 0 of 4 plus 4h plus h squared minus 4 all over h. Well, this is when you get excited. These are some of these problems where you're like, hey, I absolutely know that I've got the answer right, because what's going to happen is these numbers are going to cancel out, the 4 and the minus 4. And now you're left with two h's that I can actually factor out an h, and that's exactly what we want because I can't plug in the 0 here yet. I want to be able to cancel it. So this is going to be equal to limit as h approaches 0. I'm going to pull out the h and have a 4 plus h. Do you guys see that? I just took this and factored out the h. And that's obviously going to be divided by h. Here our h's cancel. And now all I have to do is just plug my 0 in, and I get 4 plus 0, which is 4. So what's the slope of that line? Well, the slope of that tangent line is 4 when a equals 2. All right, whoa. I guess I have the answer there. All right, now I was actually asked to find the equation of the tangent line at x equals 2. So to do that, I have to just erase all this. I got kind of taken back by all this stuff that just popped up. But then I remember, yep, I got to do this. All right, so we know that our slope is 4. And that's huge, m equals 4. But it actually wants to know what the equation of the line is. So it actually wants to know, oh, I feel like that wasn't great. Let me try it again. Come on, Miss Sorensen. That was, I nailed that one. Sometimes you gotta pat yourself on the back, not on the bat. Don't pat a bat. All right, find the equation of the tangent line. Well, we've already found that the slope is 4, but we need to be able to find the equation of the line. From here on out, I'm going to actually ask you to use the point slope form. This is point slope form. And I know that's kind of awkward, but this is the equation that we're going to use mainly in calculus. You're usually used to y equals mx plus b, or even ax plus by equals c. This is standard form, and this is slope-intercept form. But in calculus, we're going to use the point-slope form. So to create this equation, it's really as simple as the following. You just get your point. Well, we know our point is 2, 4, right? We took this 2 and we plugged in to get 2, 4. That's our x1 and our y1. So our final answer is going to be y minus 4, right? y1 is 4, equals my slope, which is 4, and then x minus 2, because my x1 is 2. And that's it. That's the equation. You certainly could multiply through, distribute, and then get y equals mx plus b, and see that you get the same answer if you were to graph it. But I want you to leave it in point slope form. All right. Oh, look how well I did. All right. Next one, example 2, find the slope of the line tangent to the curve f of x equals 4x plus 2 at x equals 3. All right, so we're going to go ahead and write my slope equals the limit as h approaches 0 of f of, well, my a is 3, so that's going to be 3 plus h minus, well, what is f of 3? That just means plugging in 3 all over h. So it's going to be equal to the limit as h approaches 0. I'm going to take 3 plus h and I'm going to plug it in wherever I see an x. So this is going to be 4 times 3 plus h. And then plus 2. Don't forget that. You still have to write this whole entire thing. It's just that instead of an x, you're putting in the 3 plus h. Now I can do the minus right here. Just to highlight it, I'm doing this minus. And then I'm going to do f of 3. Well, what is f of 3? Well, that's the point, 3 comma. So I plug in 3. That's 4 times 3 is 12, plus 2 is 14. So my value is 14 when I plug in 3. So this is going to be minus 14 all over h. This one's kind of nice because you don't have to do FOIL. I'm just going to do distributive property. So I'm going to multiply through here and here. So it's going to be 12 plus 4h. And then don't forget about the plus 2. And then the minus 14. And this is going to be all divided by h. Now at this point you're hoping something cancels, and if it doesn't, you've done something wrong. But you've got that 12, that plus 2, which is 14, and then you minus the 14. So all of these cancel. So we're left with the limit as h approaches 0. And now I've got just a 4h over h. The h's cancel, and I'm just left with 4, which is kind of interesting, right? That means that we don't even have to plug in 3, and we get 4 as our slope, which we'll talk about why in a second. Kudos to you if you see why already. So now we have to go ahead and write the equation of that line. I think it's going to say that next, and that would be y minus y1 equals mx minus x1. So that's going to be y minus, well, what's my y value? 14 equals my slope of 4, and then x minus 3. That's coming from this x value here. And that's the equation of our tangent line at that point, and we know that that equation has a slope of 4. All right, let's go ahead and talk about what this means. This is saying that at x equals 3, all right, you guys can deal with that. At x equals 3, the slope of that tangent line is 4. And so it's a little bit off the graph, 1, 2, 3. It'd be like, I don't know, way up here. And you're saying, hey, what's the slope of that tangent line? Well, for a line, the tangent line is going to be this right here, tangent to that point. And so why is it 4? Well, look, it's a line, and the slope is already 4. So at every single point on this graph, no matter what x value you choose, the slope of that tangent line is going to be 4 because it's a line. And so that's why we get 4. It matches that. That only is true for linear equations. All right, here we go. I believe this is the last one. Yeah, it is. All right, stay with me. If you want, you can go ahead and try this on your own, but this is certainly a harder problem that you should stay with me and do. Don't just skip this problem. So this one's going to be m equals the limit as h approaches 0 of f of, here's my a is 4, so that's going to be 4 plus h minus f of 4 all over h. So next thing I'm going to do is I'm going to plug in 4 plus h everywhere I see an x. And I should put parentheses, minus parentheses 4 plus h squared plus 2 parentheses 4 plus h. All right, so I've plugged in for both of those things. And now I have to do minus f of 4. So let me go ahead and put a minus. That's that minus right there. And now let me find f of 4. Okay, well, f of 4 is going to be minus 4 squared plus 2 times 4. Well, 4 squared is 16. Then put the negative. That's a minus 16 plus 8 gives me negative 8. So I've got the point 4 comma negative 8. All right, so I'm going to have minus a negative 8, which of course we know becomes a plus 8. And this all goes over h. It's now our duty to simplify this and then hope that things cancel. So let's go ahead and start with the 4 plus h squared, which is 4 plus h times 4 plus h. That gives me a 16 plus an 8h plus an h squared. So I'm going to rewrite this as the limit as h approaches 0. And don't forget, I have a negative in front of this 4 plus h squared. So I actually have to make this a negative 16 minus 8h minus h squared if I keep my negative right here, which I must. So that whole thing, let me just highlight that so you can see what I'm talking about. This whole thing right here is going to become a negative 16 minus 8h minus h squared. Then let's do the distributive property. That's going to be a plus 8 and then plus 2h. And now I've got my plus 8. And that's all going to be over h. So now let's see what cancels. We've got a plus 8 and a plus 8. So that's 16 minus 16, and that all disappears. So now I'm left with the limit as h approaches 0 of a, let's see, a negative 8h and a 2h becomes a minus 6h, and then a minus h squared, all over h. All right, this becomes the limit as h approaches 0. I'm going to pull out that h now. Let me get rid of this so we have more room. So pulling out the h, I have a minus 6 minus h all over h. My h's are going to cancel. Now I'm going to take that 0 and plug in. And so that gives me a negative 6 minus 0, which is equal to negative 6. So my slope is negative 6. Well, I need to find the tangent line at x equals 4. So remember, my coordinate is right here. So to write that equation, I'm going to have y minus my y1, which is minus 8, equals my slope of negative 6 times x minus my x1 is 4. And of course, we should write this as y plus 8 equals negative 6, x minus 4. All right, so let's take a look at what we found. We just found that we've got our equation negative x squared plus 2x, which is in red. All right, so this is in red. And then my equation is actually in blue, right? So I've got this represents the equation of my tangent line. And you can go ahead and see that we're talking about the point 4, negative 8. It's a little tricky to understand because your origin is actually here, but this is 4, negative 8. The point right here is 4, negative 8. And you can see that the slope here is a negative 6, right? We're going down 1, 2, 3, 4, 5, 6, right 1. So I've kind of checked my answer. Thanks for watching, everyone. I know this is a long topic, but you are wonderful people. Bye now.